Welcome, my friends. In this video, I will be introducing perhaps the three most important trigonometric identities, which are the Pythagorean identities. Unsurprisingly, these identities come from the Pythagorean theorem. Let's take a look at this triangle, which has a hypotenuse of 1. Let's designate this angle as theta. We know that cosine of theta is the adjacent side divided by the hypotenuse. In this case, since the hypotenuse is 1, cosine of theta is adjacent over 1, or just the adjacent side. Let's put cosine of theta onto the triangle as the adjacent side. Sine of theta is the opposite side divided by the hypotenuse. In this case, since the hypotenuse is 1, we will just have opposite over 1, or just opposite. So that means sine of theta is equal to the opposite side, if the hypotenuse is 1. We can put sine of theta onto the triangle. Let's apply the Pythagorean theorem to this triangle. A and B in the Pythagorean theorem refer to the legs of the triangle, which will be cosine and sine. C represents the hypotenuse, which will be 1. So we have A equals sine of theta, B equals cosine of theta, and C equals 1. If we apply the theorem, we will have that A squared, or sine squared, plus B squared, or cosine squared, is equal to C squared, or 1 squared, which is just 1. This is the first of our three Pythagorean identities. Sine squared plus cosine squared is always equal to 1. Now we can take this identity and manipulate it to find two more Pythagorean identities. If we divide everything by sine squared of theta, and we look at the right-hand side, we see that we have 1 divided by sine squared of theta. 1 over sine is cosecant, so 1 over sine squared will be cosecant squared. Sine squared over itself is just 1. And cosine squared over sine squared is cotangent squared. Altogether, we have 1 plus cotangent squared is equal to cosecant squared. This is the second of the three Pythagorean identities. Alright, to get the last Pythagorean identity, we will take the first Pythagorean identity, and now instead of dividing by sine squared, we will divide by cosine squared. On the right-hand side, 1 over cosine squared is the same thing as secant squared. Sine over cosine is the same thing as tangent, so sine squared over cosine squared will be tangent squared. Cosine squared over itself is just 1, so we have tangent squared plus 1 is equal to secant squared. More commonly, you might see this written as 1 plus tangent squared is equal to secant squared. These are the three Pythagorean identities. It's absolutely worth your time to memorize these identities. Typically, students are able to memorize sine squared plus cosine squared equals 1 relatively easily. It's the other two that are more difficult. I always remember that 1 plus a squared tangent-related function is related to an identity. So if I ever see 1 plus either cotangent squared or 1 plus tangent squared in a problem, I know I can convert that to something using an identity. Eventually, I was able to remember that 1 plus cotangent squared is equal to cosecant squared, and 1 plus tangent squared is equal to secant squared. Altogether, these are the three Pythagorean identities. Please take some time to try to memorize these. It will absolutely be worth your time. Let's try some practice simplifying trigonometric expressions related to the Pythagorean identities. Here we are asked to simplify the expression 1 plus cotangent squared times sine squared. As I mentioned a moment ago, I always remember that 1 plus a squared tangent-related function, either tangent squared or cotangent squared, is an identity. More specifically here, 1 plus cotangent squared is the same thing as cosecant squared. So we can rewrite 1 plus cotangent squared times sine squared as cosecant squared times sine squared. Then we know that cosecant squared is the same thing as 1 over sine squared by the reciprocal identity. The sine squareds will cancel, and we will be left with just 1. 1 plus cotangent squared times sine squared is the same thing as 1. Let's try another one. We are asked to simplify the expression secant of x minus secant of x times sine squared of x. Now, the Pythagorean identities only relate to squared trig functions, and the only squared trig function we have here is sine squared. Remember that the first Pythagorean identity is that sine squared of x plus cosine squared of x is equal to 1. We have sine squared of x in our problem, so we can solve for sine squared of x by subtracting cosine squared of x from both sides. We will get that sine squared of x is equal to 1 minus cosine squared of x. In our problem, we have secant of x minus secant of x times sine squared of x. We have found an expression in terms of sine squared. It's 1 minus cosine squared, so substitute that in for sine squared in our problem. We have secant of x minus secant of x times 1 minus cosine squared of x. We can distribute the secant to both of the terms in parentheses to get secant of x minus secant of x times 1, which is secant of x, plus secant of x times cosine squared of x, since the negative signs cancel. The two secants cancel, and we are left with secant of x times cosine squared of x. We know that secant is the same thing as 1 over cosine, so we can convert this into 1 over cosine times cosine squared. One of the cosines in the denominator will cancel with one of the cosines here. Altogether, we will have cosine of x. Let's try this one. We are asked to simplify the expression tangent squared times secant squared minus tangent squared. The Pythagorean identities relate to squared trig functions, so we could apply a Pythagorean identity either to this tangent squared, this secant squared, or this negative tangent squared. So which one should we do? Well, remember that 1 plus tangent squared is equal to secant squared. Perhaps we would want to convert the secant squared into tangent squared, since we already have two tangent squareds. It will be more likely the case that we can simplify our problem. So we have tangent squared times secant squared minus tangent squared. Let's substitute 1 plus tangent squared in for secant squared. We will have tangent squared times 1 plus tangent squared minus tangent squared. Let's distribute the tangent squared. We will get tangent squared plus tangent to the 4th power, since these are both to the 2nd power and we can combine the exponents, minus tangent squared. We have tangent squared and minus tangent squared, so those will cancel. Our final answer is tangent to the 4th power. Alright my friends, that finishes this video introducing the Pythagorean identities. We will use these identities over and over and over again, so it's absolutely worth your time to try to memorize them.